Hello guys, I am Shrikant.
And I'm Krunal.
Today we are going to discuss the questions on interface flux. These questions were taken from PYQs, assignment and books. So the first question is, a Newtonian fluid with a viscosity of 50 centipoise is placed between two large parallel plates separated by a distance of 8 mm. Each plate has an area of 2 meters square. The upper plate moves in positive x direction with a velocity of 0.4 meter per second, while the lower plate is kept stationary.
So in this question, we have given two parallel plates. So both plates have an area of 2 meters squared and the separation between two plates is 8 mm. Also, we have given that upper plate is moving in x direction with a velocity of 0.4 meter per second and the lower plate is kept stationary, so its velocity will be 0. So we can now form two axes. So this is x axis and this is y axis, and we know that momentum is transferred in y direction while the velocity is in x direction.
So now we will move on the first part of the question, which is part A. So the part A is, calculate the steady force applied to the upper plate.
So we have two plates. Lower plate is moving with velocity equals to 0 and upper plate is moving with velocity equals to 0.4 meter per second. And this upper so we have fluid which is viscous. So our fluid is resisting the flow of upper plate, but still it is moving with a constant velocity. So it needs to have a push or a force. So we have to calculate that force, F.
So the given data for part A, first one is, so the viscosity is 50 centipoise. And the next one is plate separation, which is 8 mm in y direction. We will written in SI unit, which is meter. And next one is the area of plate, which is 2 meter square, and the velocity of upper plate is 0.4 meter per second, and the lower plate is kept stationary. So this is the classical Newtonian shear flow between the parallel plates. So now we will move on the solution parts. So the step one is, we have to calculate the shear force. Shear force, and the shear force is given by tau is equal to mu dv by dx, where mu is the constant and this is the velocity gradient. And now calculating the shear force is given by tau by x mu dv upon dy. This is our basic formula of shear force. Now we are putting the values. Values are, we are taking values from given data that are now putting the given data. Tau yx is equal to 50 into 10 to the power minus 3, that is mu, and velocity upon distance. After solving this, we are getting 2.5 Pascal, that is our viscosity. Now from this we are going to find the force. Now we are moving towards the main part of our question, that is the measuring the force, and the force is equal to tau into area. Now tau, we are now above we found the tau, and the area is given in previous data, that is 2 meter square. After solving this, we are getting the force, which is 5 meter.
So we will move on to the B part of the question. So the question is,
So the question is, the fluid in part A is replaced with another Newtonian fluid of viscosity 5 centipoise. Another Newtonian fluid of viscosity 5 centipoise. If the steady force applied to the upper plate is the same as that of part A, calculate the velocity of upper plate.
so as we know, we have two plates and fluid between them. The separation is still 8 mm and area is 2 meters square. But now we have to calculate Vx, while Vx of lower plate is 0, means it is stationary, and we have given force, which is in last part of the question. We have given force, so we have to calculate Vx. If we are providing a force of 5 Newton, what will be the velocity of upper plate when this fluid have an viscosity of 5 centipoise?
So now we will move on to the solution part of part B. Basically, the given data for this question we are taking from the previous question as same. So here we have to find the new velocity for the plate. So given data is our new viscosity, which is 5 centipoise, which is equal to 0.005 Pascal, and our force is 5 Newton, where area is same as previous question, which is 2 meters square. Now we have to find the velocity which is applied on the upper plate of Okay, now we have to find velocity applied on upper plate, and the y is equal to 8 mm, which is equal to 8 into 10 to the power minus 3 meter. Okay, now we have to solve this question from the given data. We have given force which is equal to tau into area. Now how can we write this? Tau is equal to basically mu into v by 1 into area. We have to find the velocity, and the given quantity is force is equal to 5, mu is equal to 15 to 10 to the power minus 3. No, sorry, it's okay. Our new viscosity is 5 into 10 to the power minus 3, and the velocity is we have to find, and the y is equal to 8 into 10 to the power minus 3, and area is 2 meter square. Now after solving this all given data, we are finding that v is equal to okay, now we are going to find the velocity from this data. This is cancel out, 10 to the power minus 3, 5 will be cancelled out, and now what is the remaining? V is equal to 8 upon 2, which is equal to 4 meter per second. And now this is the v is equal to 4 meter per second new velocity, which is applied on the upper. So now moving to our next question. Our next question is 1 liter ethanol is poured into a cylindrical tank of 4.5 liter capacity. Cylindrical tank of 4.5 liter capacity, and the top is quickly sealed. The total height of cylinder is 2.5 meter. Cylinder is 2.5 meter. Calculate the mass transfer coefficient. If the ethanol concentration in the air reaches 9% of its saturation value, in 7 minutes, the cylinder temperature is kept constant at 20 degrees Celsius. The density and saturation pressure of ethanol at 20 degrees Celsius is 789 kg per meter cube and 43.6 mmHg.
So we have a cylindrical tank of 4.5 liters capacity. So we have this cylindrical tank and we are pouring 1 liter of ethanol in this. So 1 liter, so maybe this side. Is we are pouring ethanol and then we are sealing the top. So ethanol cannot escape this cylinder, and because ethanol is volatile, it will evaporate in this air. in the cylinder, and we are given that in 7 minutes, this air concentration, or ethanol concentration in air is reaching 9% of its saturation value. That means partial pressure of ethanol is reaching 9% of P saturation or saturation pressure. Okay. The height of this cylinder is 2.5 meters, and we have to calculate mass transfer coefficient. Means here mass transfer is occurring, and we have to calculate mass transfer coefficient, that is MTC. So this question is required to calculate MTC, that is mass transfer coefficient.
Now moving towards the solution part of this question. So our given data is, first of all, volume of ethanol is 1.5 liter. Sorry, that is 1 liter. Which is equal to 10 to the power minus 3. Next one is total tank capacity. Which is equal to 4.5 liter cylinder, and the cylinder height is 2.5 meter. Surface area will be our volume of liquid upon height, which is equal to our 4 meters square. And our next one is time, which is 7 minutes. In second is 420 seconds, and the ethanol reaches 9% of saturation. Which is CA equal to, can be written as CA is equal to 0.09 CAR. And our density is 789 kg per meter cube, and our pressure, saturation pressure is given in 43.6 mm of Hg. We are going to convert it into ATM. For that we can written as is equal to R is equal to 0.08205 ATM liter mole per kg, and our temperature is given by 293 Kelvin.
So moving further. So firstly, we have to convert P saturation into CaW. So CaW equals to P sat by RT. So that is equals to 43.6 by 760 divided by R, which is 0.08205 into T, that is 20 degrees Celsius, but we have to convert it into Kelvin. So we will add 273 here, and it will be equals to 2.39 into 10 power minus 3 kilomole per meter cube. So moles evaporated are, we have to calculate moles that are evaporated. So Na equals 9%, that is 0.09 into CaW, concentration of ethanol in air, into volume of air. So 0.09 into CaW, that is calculated above, 2.39 into 10 power minus 3 into volume of air. So volume of air is 3.5 because total volume is 4.5. So volume of air will be 3.5 because total volume is 4.5 and volume of ethanol is 1 liter. So 4.5 minus 1, that is equal to 3.5 liters. So 3.5 into 10 power minus 3. So this is equals to 4.48 into 10 power minus 6 kilomole per meter square second. So now we will calculate molar flux. The molar flux will be equals to moles evaporated per unit area per unit time, that is equals to 7.53 into 10 power minus 6 minus 7 divided by area, that is 4 into 10 power minus 4 into time. So time is we know that 420 seconds. It is equal to 4.48 into 10 power minus 6 kilomole per meter square second. So now we will move to calculate mass transfer coefficient. As we know that NaW equals to mass transfer coefficient into CaW minus CaW in air. So we know that CaW in air will be 0 because initial concentration of ethanol in air will be 0. So this will be equals to Kc, that is mass transfer coefficient, into CaW. What is CaW? So CaW will be 2.39 into 10 power minus 3, and NaW, we have calculated NaW as 4.48 into 10 power minus 6. So Kc will be 2.39 into 10 power minus 3 divided by 4.48 into 10 power minus 6. That will be equals to 1.875 into 10 power minus 3 meter square per second.